Nth roots. This basically, I'm going to rock your world today in a mathematical sense. So what I mean is I'm basically going to throw a rock in an ocean and you guys aren't going to really notice much difference. But this is a big deal, all right, as far as success going forward is concerned. Let's go next slide here. And the part that I'm going to rock your world with is the fact that this is a square root, right? We just talked about those. You just took your lesson check over those. That's all fine and dandy. The fun part is that's actually not a square. It's not a exclusively square root sign. It's actually a type of a radical sign. Okay, it's actually a type of radical. It's actually a part of something. Anybody ever hear the expression all thumbs are fingers, but not all fingers are thumbs? Okay, we've all heard that, right? All your thumbs are considered fingers, but not all your fingers are thumbs, right? Kind of the same thing here, okay? All square roots are considered to be radicals, but not all radicals are square roots. We have different kinds of radicals. We have different kinds of roots, okay? Most notably, honestly, is a cube root, which is probably, if you've seen one before, that's the one you've seen. Okay, just for a quick example, it would look like that. Okay, if you've messed around with your math, if you have your calculator right now, hit math on it, and then if you look, I think it's option 4 or 5, one of the two, you'll see that. Okay, you'll see that there. Mr. Taylor.
Is that an n above the square root on the notation?
Yes, yes it is. There's an n right there, yes. Okay. So, radical is another term for nth root. So basically, nth root is the collective name of all of them. Your cube root, your fourth root, your fifth root, your sixth root. Instead of saying all the numbers, they just use n as a general term. Okay, this makes sense on that part. General notation of it, okay? Square root, like they say, most commonly known. So one you guys have been working with for a while now, so you know that part. Now, the biggest and most important part to this slide, this lesson, the next lesson, and maybe the lesson after that, is this box right here. Whoop, lost it on the trials there. Sorry, ADD kicking in. That box that I just had, let me actually put one up there now. This box, most important definitions of the chapter. And honestly, the most important definition of the whole thing is that right there. Okay? The notation for your nth roots will be n, this little n that Javon pointed out earlier, radical sign r. Now this n is going to be a number. Okay? It's going to be a number. So it'll be like a cube root like that. This number is what's called the index. Okay? That number is called the index. What it does to your problem, we will explain later. But know that that's called the index. Okay? No spoilers. It's okay. The inside stuff is called the radicand. Alright? The inside, whatever's on the inside of your radical, that's called your radicand. Okay? And that's just the general term. That goes for all of them. Okay, now, here are some examples on the right-hand side of some cube roots, but here's the gist of this slide. You won't have a quiz. Okay, the other two classes, they get pop quizzes over these. You guys won't. But what I do need you guys to know, and this is for your benefit, you guys need to know the perfect squares from 1 to 144. Okay, you really need to know perfect squares from 1 to 144 because they make your problems a lot shorter. Okay, whenever you're working on stuff, they make it to go a lot faster, a lot shorter. For that same reason, you really need to know the cube roots from 1 to what ends up being 216. The cube root of that is 6. Okay, so the cube root of 1 is 1. Cube root of 8 is 2. Cube root of 27 is 3.
You want to write those down?
I would, yeah. Cube root of 64 is 4. Cube root of 125 is 5. Cube root of 216 is 6. This is the one in just a minute, after you guys are done writing, that we're going to do it, and then we're going to see why it turns it into 6. Okay? But for your benefit, I would try, I don't want to say memorize, but memorize those 18. Like I said, you're not going to have a quiz over it or nothing, but the more you know of those, the easier your problems become. Okay? So, like I said, we're going to look at the cube root of 216 and figure out why it's 6. Okay? I already told you the answer is 6. Let's figure out why. Okay? Now, when you see that, yesterday you what? You did factor trees. Let's do the same thing. Okay? Except I'm going to do these factor trees in a very specific way. I'm going to cut them down by 2's first. So 216, I'm going to divide it by 2. That goes to 2 and what ends up being 108. Okay, right? 2 times 10 is 20. I'm going to go down by another 2, and that gives me 54, right? So I'm going to check my math. Okay. I'm going to cut it down by another 2 because it's even. That gives me 27. Still good? Okay. Now I'm going to take 27. 27 is not even, but I know 27 is 3, so there's a 3. And it goes with a 9. And then 9 goes 3 and 3. Okay?
Sure. So when you did the calculations of 108, like for that when you was doing it, can you like also do it with 9 times 12?
You could.
Okay.
Yeah.
But would it take like a lot of work?
No.
Oh,
Okay. I just did it by 2, so that's all.
okay.
Okay.
I would just asking.
Okay. Now, yesterday, I'm going to do this in red because this is yesterday, not today. Yesterday, we would look for what?
The same numbers.
How many times?
2.
Twice. Good. We would go through and circle our pairs. There's a pair, and there's a pair. And then we would go through. Don't do this. And then we would go through and say, oh, look, this 3 is left over, this 2 is left over. We do 6 on the outside from the red 2s and the red 3s. We do 6 on the inside from the green boxes left over. That was all yesterday. Today, we're doing the cube root, not the square root. That 3 tells you the number you need in your groups.
What do you mean by that?
You don't look for pairs. This time we're looking for groups of 3. The number you need in your groups. We don't need 2 anymore.
So if it was 5, it would be
You would need 5 in a group. Right. Okay? So we don't need 2 in a group right now. We need 3 in a group. So other than that, stays the same. Go through, look for your groups of 3. Cody.
If you just had like 3 2s and then just 2 3s, how would that work?
We'll worry about that one later.
Okay.
Okay? Today, these actually all work out nice. But just like how they're left over in a square root,
It would be the
you would
same.
put them back. Yeah,
Okay.
yeah. Okay? But today, they're all perfect. That's the nice part about today. All right? So today, we're looking for groups of 3. Or at least for this one, rather, we're looking for groups of 3. So here's a group of 3 2s. And then here, a group of 3 3s. And then notice how all your prime factors got circled, or all your numbers are circled, right? So that means you're going to have no radical left over. That's going to happen every time today. This whole lesson, everything works out perfect. Okay? Tomorrow that changes. Today, these are all perfect. So we have these 3 2s. They all still come out as 1. Okay? That part doesn't change. So those 2s come out as 1. Those 3s come out as 1. Still multiplication. 2 times 3. 6. All right, next. Square root 16 Oh boy, something you've never seen before probably. Y to the 4th. Okay. Javon.
Wouldn't that just make it 4y squared?
Yes. Good job. Good job. Yep. Okay. 4y squared. That's exactly it. Take them part by part. Okay. Part by part. Go with the number first. Now notice how we're doing a square root again. Okay. Now square root's the only time that you won't see a number here in your index. Okay. So whenever that's the case, you go back to looking for pairs. Okay. So 16 factor trees to 4 and 4. To be honest, I don't need to see that factor tree because I'm wanting you guys to know that instantly that the square root of 16 is 4. Okay, so I don't need to see that factor tree. There's very little work you actually need to show me here. Very little. Okay, so the 16 is 4. Okay, that's one part. Now let's handle the y's. How many y's are up there?
4.
There's 4 factors of y, right? Because it's to the 4th power. Okay, so we have y, 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 and y. How many do we need in a group? 2. There's a group of 2. There's a group of 2. So how many groups do we have? 2. Y squared.
I think I know what we're doing on this one.
Good.
So basically we're gonna have a problem like
Next one. Fourth root of y to the 4. Okay, so same thing. You have 4 factors of y just like last time. Except this time, how many do you need in a group? 4. So there's your 4. They all come out as 1. 1y. The end.
That was a toughie.
I know. Okay, I know. Yeah, that was rough. Okay, hope we can handle that one. Everybody okay? Everybody good? Okay, next one.
Is that to the 6?
It is, yes.
So you mean like y6s, like 4 6. I mean, I said 4 6, but 6 4 6 y's. Yes.
Now you got it. So square root of 36 is what? 6. Okay, so like I said, I don't need to see that factor tree. You know, if you can go straight to the 6, that's cool. And then y to the 6, so think about it. You have 6 y's total. You need to put them in groups of what? 2. Groups of 2. 6 total. How many groups do you have?
3.
3. That's what the exponent is. What's the shortcut? There is a shortcut.
Divide by 2.
Divide almost. On this one, yes. Use a vocab word.
The index.
Divide by the index. Good. Okay.
Okay.
You divide by the index.
How'd you get 3 y left?
Yeah.
You have 6 y's total, right?
Square.
Okay. You have 6 y's. Put them in pairs. There's 1 pair. There's 2 pairs. There's 3 pairs.
Oh, okay.
Okay. Now, if you don't see the index, that's kind of the only hard part. If you don't see the index, like I said, it's 2. So the way the variables work, as long as it's perfect, you just do exponent divide by index.
But if, so if, that, if it was a 3 right there, it would be y squared?
If this was a 3, yeah,
it'd be y.
then yeah, yep. Okay. Exponent divide by index, and then. All right.
Because it's 2 because it's 6 instead.
Right. Cool. Next one. Okay, there you go. Okay, so we don't know right away the 5th root of 243. And that's okay, you'll get something like that, all right? But we can start cutting it down with factor trees, right? So we know it's divisible by 3. And that when you divide that by 3, you get what?
You get 81 and 3.
You get 81 and 3, good. All right? Now, from here, yes, there's a lot of roads you can go. Most of us are probably going what?
9 and 27.
9 and 9.
9 and 9.
Oh, you talking for that? I think.
Yeah. Okay? And from 81, most of us are going to go 9 and 9, as I recommend you do. Okay? I want to show you guys one thing, though. And the reason why I want you guys
3 cubed.
to know those cube roots. Instead of going 9 and 9, I'm going to go 3 and 27. Okay? Now, from the slide, that's a terrible 3. Let's try that again. Hold on. There we go. Why do we write these leaves of this factor tree like we do? What's the point here? These two numbers what?
I'm trying to find pairs of 3 now.
Right, but why can we write this like this? 3 and 27 what?
Factor in each other.
Close. Why can we go from 81 to 3 and 27? Why can we go from 243 to 3 and 81?
Because they all go into 243.
Because they all go into 243, but specifically to this part of the tree, 3 and 27,
Go into 81.
what's 81? Looking for an M word.
Oh no, it's the,
Multiply. Atta girl, Miss Pearson. Okay, they multiply, right?
I thought we said that.
I don't think so. Do we? Okay. They multiply back up there, right? And as long as, and here's the crazy part, ready? As long as that whole branch of that tree, to put it in factor tree sense, as long as that all multiplies back, cool. And since now I know that 27 is a perfect cube of 3, is there anything wrong with that?
Nope.
No.
I didn't even think of that.
You could just do it for any one year.
You could. But here's the thing, Hughes. Nowhere else in this PowerPoint do I have a chance to tell you guys that. So I got to pull it out here. Okay. So you can make as big a factor tree as you want to. I don't advise going much past 3 though. All right. Maybe 2 if you're doing all, or maybe go to 4 if you're doing all by 2s or something like that. Okay. Now, how many do we need in our group? 5. 1, 2, 3, 4, 5. Look at that, how that works. There's your 5 threes. They come out as 1. Remember, it's a exponent divided by index. So A is to the what power? A is to the 4th, and B is to the good stuff. No, you don't. You do not need a calculator. Not in the slightest. X
After the 6.
x squared minus 6 in parentheses to the 8th power. All underneath a square root. No. Not everything.
Or not the 8th power.
So wait.
But wouldn't it be x minus 3?
No. Okay. Let's hang tight. Let's get one thing. Let's get first thing straight here. Okay. First things first. The inside here, come on, finger, does not turn into x to the 16th minus whatever huge number 6 to the 8th power is. Okay? Okay? You can't just put this 8 to each one of these and call it good. Okay? So that's not what you do. Not in the slightest. Ever would you do that. Because remember, if you're going to do that binomial, you've got to write the binomials out every single time. Right? Okay. Now, when somebody just said it when you foil, okay? Also not what you want to get accomplished, but you need to kind of use that logic. Okay? You don't need to foil this at all, but you kind of have to use that line of thinking just a little bit. All right? First question I have. What are we taking the square root of? No.
6.
No.
X.
6.
No.
Is it X?
Somebody say F.
Say what, book?
X the square root.
Yeah, what are we taking the square root of? Oh, what was that? What was that? Hold on.
2. The whole thing.
The whole thing. What's the whole thing?
X squared minus 6.
Good. We're taking the square root of x squared minus 6 because it's in parentheses, right? And parentheses group things together, right? Okay? So since it's in parentheses, it's together, right? Okay? So how many x squared minus 6's do you have? 8. I'm doing this one time. You don't have to.
So you don't have to.
You don't have to. Just watch me. Is that 8? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, go me. We have 8 x squared minus 6's. Right? How many do we need in our group? 2 in a group. There's 2. There's 2. There's 2. And there's 2. So of our x squared minus 6's, how many groups do we have?
That's what I said from the beginning. I said we just do that too.
So how do we factor tree 64?
8 and 8.
8 and 8. Okay, since we know it, that's a good start. All right, now don't get in the habit though. You have to pay attention to that index. Okay, because what you guys are in the habit of is seeing pairs and circling them and going from there. How many do we need in our group this go round?
6.
Need 6. Okay, that's a lot. But 8 goes 4 and 2, and then 4 goes 2 and 2. All right, and like I said earlier, this is where knowing your cube roots can come in handy because 8 actually just goes 2, 2, 2, right? Okay, see that? So how many 2's do we end up with? Well, okay, yeah, but of your factors you end up with 6, which all come out as 1. There you go. Okay, 1, 2. There we go. Okay. Surprise, surprise, it worked out perfect. All of the ones you have today will work out perfectly. Won't be the case tomorrow, but today at least it will. All right. Then for your binomial, that x squared minus 3 part, remember the inside never changes. Okay, inside the parentheses doesn't change. Only thing that changes is this exponent right here. This one turns into what?
3.
3. Good. 18 divided by 6.
I didn't even see the index in front of
Yeah, that's a big thing you need to make sure you get. That index is a big number. If you don't, and I mean this sincerely, it doesn't matter what I say or what I'm teaching you guys past today if you don't understand how your index affects a problem. Everything past today is completely irrelevant to you if you don't know how to handle that index. If you don't know how to handle that index, nothing I say the rest of the chapter will matter or make sense. That's how important that number is. Okay? It is the smallest, most important number you see. Okay? No doubt. So, last one here. 16 goes 4, 4. Each of them 4s goes 2, 2. So there's your 4 2's. Coming out as 1. Square root x minus 3. And that 12 turns into a 3. Fourth index turns into a 3.